So we're in AP Calculus. Today's date is Wednesday, November 6, 2019. We're doing self-check 4.3. We're doing 5 questions. We had 10 minutes. Here we go. We have this function, which the following is the equation of the line tangent. Whenever you see the word equation and line tangent, you should immediately go y minus box is equal to box times x minus box, where this box is our y1, this box is our slope, our f prime, and this box, I need the parentheses here, should be our x1. All right, so x is -1. We can immediately fill in -1 right here. We don't know what the y-coordinate is, but we can find the y-coordinate by plugging in -1 into all of these x's, and that will be the y-coordinate. So here I go and do that. 4 times -1 to the power of 3 minus 5 times -1 plus 3. -1 to the power of 3, shout it out, is? -1 times 4 is? -4, perfect. -1 times -5 is? +5, +3. So 5 plus 3 is 8. 8 minus 4 is 4. So I know that my y-coordinate right here is 4. In order to find, oh wait, my y-coordinate is 4. There we go, Mr. Sindel. And then I need to take the derivative and plug in -1. That will be this point right here. Again, another way of saying this is f prime of x1. If I do that correctly, f prime of x, the derivative of 3 comes down and multiplies by the 4, so it's going to be 12 x to the power of 2, 12x squared, minus 5 plus 0, derivative of constant goes away, and then I need to plug in -1. So f prime of -1, that's going to be 12 times -1 quantity squared minus 5. -1 squared is just 1, so 12 minus 5 is 7, so the slope here is clearly 7 and not -5. Which of these has a slope of 7? It's not D and E. I need to distribute the 7 and to get it into the slope-intercept form, so this is going to be x plus 1. A double negative makes it plus 1. 7 times x is 7x. So I have, now on the right-hand side, I have 7x. 7 times +1 is +7, but I also need to add 4 to both sides, so if I add 4 right here, I get 7x plus 11. So this is actually 7x plus 11. This was y minus 4 is equal to this. Y is equal to 7x minus 11, or plus 11, and the answer is C. I can change this color to black. That makes more sense.
Did you learn this unit, or was it the past unit?
That was the past unit. All right. Wait, are these the right? Yeah, they are. Okay, I'm like, these seem off. Yeah, but this is a review. This one is definitely brand new. All right, so we have twice differentiable, and it tells us the derivatives. What is the approximation? So if I'm ever looking for the approximation, I'm using the line tangent. It even tells you using the line tangent. Okay, so if I'm using the line tangent, again, I say y minus blank is equal to blank times x minus blank. You know that I need 3 values. It tells us that x is 2, so this is going to be 2. We know that when I plug in 2, I get out 1, which means the x-coordinate here is 2, the y-coordinate here is 1, so the y-coordinate is 1. It also tells us the derivative at 2 is 4, so the derivative at 2 is 4. So I have my equation. If I rewrite my equation, y minus 1 is equal to 4 times, I'm going to leave that blank, minus 2. This should be an x here, but I'm going to approximate at 1.9. So if I plug in 1.9, I actually can do some math here. 1.9 minus 2 is just -0.1. That needs to be multiplied by 4. And then I need to add 1 to both sides. I can just add that on right now. Plus 1. That should all be equal to y. 4 times -0.1 is -0.4. And from there, I know that y is equal to 0.6. Correct answer is B. Questions? Get your hot questions here.
So, when it's talking about the tangent, we always want to use that equation.
Always, 100% of the time. If it's only asking about the slope of the line tangent, then you're only talking about this one number. If it's talking about just the line tangent, the equation of the line tangent, you're going to need this whole thing. All right. On to number 3. All right, so now we're getting into implicit differentiation, which is a fancy way of saying we have x's and y's happening and we're taking the derivative. So y squared Take the derivative, and I get 2y prime, or 2y to the power of 1, and then dinner is y prime. I am going to confuse people by putting 1 here. It might look like a prime. So then I'm going to subtract. This is product rule because I have 2 different variables. So I'm going to write out product rule to help me out. Product rule is 1d2 plus, and then I'll just switch colors here, 2d1 to make it pop out. So 1d2, 1 is 2x. I'm going to leave the negative outside, so I'm not going to worry about the sign. I'm just going to think of it as 2xy. So 1 is 2x. D2 is y prime. And I'm going to do plus. You can change that color to black as well. Plus 2 was just y. And D1 is times, or the derivative of 1, derivative of 2x is 2, so times 2. Perfect. And then I have to copy down my equal sign, and then derivative of 21 is 0. And I have an x-coordinate, I have a y-coordinate. My x-coordinate is 2, my y-coordinate is -3. Plug those in ASAP. Plug them in now. So I'm going to plug them in, and I get 2y is -3. I still have a y prime, that's the thing I'm going to be solving for. Minus 2x, x was 2, so 2 times 2, and y prime, again, we don't know what that is. Plus, and then y is -3 times 2. This is still set equal to 0. All we did was plug in. I'm waiting for pencils to slow down so I know I'm not going too fast. And then from there, I'm just going to multiply them out. So I have -6y prime minus 4y prime is equal to 6. Again, this was -6, but I moved it to the other side, so I added 6 to both sides. And I can combine like terms. I have how many y primes? I have -10 of them on the left-hand side. So -10 y prime was equal to 6, and then dividing by -10, and then simplifying, y prime is equal to a -3/5 for the answer of, wait, is that right? Should, is it B? Okay, cool. In my notes, for some reason, I have this sign as a negative. I might have done too many negatives, though. That seems right to me. Plus y2 and y2. Oh, yeah, we did make a mistake. I see it now.
It's positive 1. It's positive 3/5.
So what we're doing here is this whole product rule, and I apologize for catching this too late, is in parentheses, which means this negative gets distributed into each of them.
Also, it's 2y. 2.
So this sign needs to change, essentially, is what I'm saying. Whenever you do product rule, you can either include -2x as the first term, or if you want to leave the negative outside, you need to do distribution at the very end. You can do either or. I did kind of a hard method, I think, because you usually will forget to do this. So maybe in the future, you should think of this as a -2x for the first term. That way you don't make a mistake. That way when I take the derivative of -2x, the derivative right here would be -2. Yes. So the answer is actually +3/5. So if I get rid of this and I change all my work, so that means down here I have a -6, a -6, and a +3/5. Again, because -3 times -2 is a +6, I subtract 6 from both sides. That's why this is a -6, and then I get +3/5. So correct answer is E. All right. So on to number 4. All right, another implicit differentiation. Here we go. So derivative of x to the power of 2 is 2x. Again, I have product rule, so 1d2 plus 2d1. And I don't have any negatives to worry about, so that makes my life a little bit easier. 1 is x, d2 is y prime, and then I say plus 2 is y, d1 is derivative of x is just 1. By the way, this should be adding right here. And I can move this 2x down so it looks a little bit better. Oh, I didn't grab the other half of that x. There we go. And then from here, I'm going to add a y to the power of 3. So add, oh, computer, come on, wake up. I'm moving, and it's not moving. It's a tablet that's not liking it. What's going on? Whoa, okay, just caught up. Plus, and then the 3 is going to come down in front, 3y squared y prime. And that's still equal to 0. I can't plug anything in, so I just need to rearrange, solving for y prime. Again, this dy dx is another way of saying y prime. So anything that's not a y prime, move it to the right-hand side. So this is not a y prime, this is not a y prime. Let's move those to the right-hand side. So I'm going to subtract 2x, and subtract y on the right-hand side. On the left-hand side, I'm still left with an x y prime plus 3y squared y prime. And again, I'm just waiting for everyone to catch up, making sure I'm not going too fast. All I'm doing is I'm moving everything that's not a y prime, because by doing that I can factor out a y prime and then it's isolated. So now is the time. I'm going to isolate y prime by factoring it out. Y prime is being factored out. What's left over? I have an x plus 3y squared, and that's set equal to negative 2x minus y. And what is my final step? Someone tell me. Yep. Divide by this thing. So if I just move it over here, technology. Actually, I'm going to go like this. I'm going to copy, paste down here, and then I'm going to move this inside down here, and I'm going to delete these and move you here, and I can change the color of all of these to black, and I just need a line. Yoink. Yeah, I think so. Cool, and there's our answer. Do we see that anywhere? Oh, they factored out a negative up here. So another way of writing this is by factoring out this negative. So negative, just put the negative out front. Now it's a positive 2x, a positive y, and on the bottom I have x plus 3y squared. X plus 3y squared. It is indeed A. All right, and our final problem was number 5, an equation of the line tangent at its point of inflection. So not only do we have to find the equation of the line tangent, then we have to find where that equation's point of inflection is. Oh, wait. Oh, at its point of inflection. Okay, so we don't know what our x coordinate is. Normally it gives us an x. It doesn't give that. The only thing it gives is its point of inflection. So first, let's find the point of inflection. That's going to be our x coordinate. Once we find that, then we can use that for the equation of the line tangent. So point of inflection. What is the definition of inflection point? It's where f, is it f prime or f double prime? F double prime sign change. There it is. Again, you should have that memorized. So I need to find the second derivative. Here we go. Y prime is equal to 3x squared plus 6x. If I take the derivative yet again, y double prime is therefore equal to 6x plus 6, and I'm going to factor him by making it 6 times x plus 1. In order to find where I have a sign change, I'm going to set this equal to 0, and if it's to the power of 1, which it is, then it's going to be a sign change. So you can clearly see our inflection point, without even doing any math, is at what? X is equal to negative 1, yeah. So our inflection point happens at x is equal to negative 1. And I know that it's an inflection point. I know it changes signs because this is an odd power. So kind of a little shortcut. Otherwise, we would have had to graph it. Okay, there's negative 1, and I have to test a point over here, test a point over here, make sure this sign is positive, this sign is negative. But the shortcut is, hey, that's an odd power. That is definitely a sign change, which means it's an inflection point because that's the definition. So we now have an x coordinate. Whew! Now we're going back to the original problem of saying y minus box is equal to box, and I'm going to make it a little bit bigger just in case it's a big number, times x minus box. All right, so I know my x coordinate. Whew, it did a lot of work. It is negative 1. I can plug that in, negative 1. I have double negative, so it's really x plus 1 on the inside, but who cares? I have negative 1. I'm plugging that negative 1 into this equation. So here we go. Oop, I don't know what happened there. If I plug in that negative 1, I have y is equal, I'm going to give some room because I want to maybe simplify right here. Y is equal to negative 1 to the power of 3, you're so fast, Gio, plus 3 times negative 1 squared plus 2. That is going to be equal to negative 1, this is going to be plus 3 plus 2, which is 4. So close. So we got 4 here. And then from here, we need to find the derivative, the slope here. The slope is going to be, we already have y prime. We already have it right here. And we can plug in our -1 into our y prime, and that will be our slope. So I can say y prime of -1. That's not a really formal way of doing it, but if I do that, I get 3 times -1 quantity squared plus, oh, that's a bad squared plus 6 times -1. And that is equal to 3 minus 6, which is just equal to -3. So the slope here should be -3. Oh, just from that. You could have just done the slope. Oh, you had to have the -1, though. We didn't even need the y-coordinate. We didn't need to plug in right here. It was unnecessary because the only slope of -3 is b. Correct answer is b. Again, if I rearrange this formula, I would get y is equal to -3x. And this is x plus 1. Distribute the -3 would be -3. But I also have to add the 4, plus 4. And this would be plus 1 right there. All right, so count out the number that you got correct. Label it out of 5 at the top left. Hold up your fingers. I got 2. Ooh, 3. Really nice. 4 and oh no, what happened, Arrow?
I just was not in the mood for it.
Got it. Okay. Yeah, so it's going to be self-check 4.4 is 5 questions, another 10 minutes. All right, self-check 4.4, which of the following is an equation to the line tangent at the point 1, 1? So at the point 1, 1, we have the x-coordinate is 1, the y-coordinate is also 1. Let's take the derivative. Well, let's actually write out the formula first. So y minus box is equal to box times x minus box. Precisely. All right, we have 1, we have 1. 1 is x, 1 is y. We just are missing the derivative, so let's do that now. So y prime, y prime of this thing is going to be 4, oh, what happened there? 4x to the power of 3 minus 3x to the power of 2 minus x, what happened there? Minus 2x plus 1. All right, and then the derivative of 1 is just 0, and then I need to plug in the x-coordinate. The x-coordinate is 1, so if I do that, I get 4 minus 3 minus 2 plus 1. Minus 3 minus 2 is -5, and that's positive, so that's 5. So I'm getting 0. Is that right? So this is equal to 0. So that means this is 0, which means my equation can be rewritten. This can turn into y is equal to 1. And that's A. Again, I'm just adding 1 to both sides. This whole thing is 0 right here, so just 1. So far, so good. No questions?
Just like I think what I thought about, I did the same equation, but I did -1, plugged in -1 instead of just 1.
Oh, okay. Yeah, so it's just a math error right here?
Yes.
Okay. Yeah, it happens. So let's do number 2. We're doing an estimate using local linear approximation, which is just a line tangent. So I'm finding the equation of the line tangent. So again, I'm doing y minus box is equal to box, the slope, times x minus box, which is the x-coordinate. All right, so what do we have? We have x equals 3, so we have an x-coordinate that we can plug in ASAP, so that's going to be 3. Do we have a y-coordinate? We do. So this is an x-coordinate of 3, this is a y-coordinate of 2, so y-coordinate is 2. Do we have the derivative? It even gives us the derivative. Oh my god, so easy. There we go, 5. And then I just need to plug in 3.1 for x, so this 3.1 is going in for x, so I'm rewriting this equation. I now have y minus 2 is equal to 5 times, and it's going to be 3.1 minus 3. 3.1 minus 3 is 0.1. 0.1 times 5 is 0.5. So I need to add 2 to that, plus 2. And that will be my y. So my y is 2.5. The correct answer is C. All right. And again, I'm just waiting for people to finish writing. And we're on to number 3. All right. So we have implicit differentiation again. So if I take the derivative, and I'm going to plug in immediately, so I'm going to have 2y, y prime, plus, and then I have product rule, so it's going to be 1d2 plus 2d1, and I really should switch this, I was trying to circle that for some reason, to yellow, so I can see what's happening a little bit better. So 1 is x, d2 is y prime, plus, and then 2 is y, d1 is just 1. And I need to set this thing equal to 6, so this is going to be equal to 0, equal to 0 because derivative of 6 is 0. Plug in immediately. Again, I have all of my x's are -1, all my y's are 3, so I have 2 times 3 times y prime plus -1 times y prime plus 3 is equal to 0. Everything that's not a y prime, let's move it to the left-hand side. So in my new equation is I have 6y prime here. 6y prime minus y prime is equal to -3. This is really 5y prime, so if I divide by 5, I get -3/5. Correct answer here is A. So y prime is equal to -3/5. So far so good. Questions, and we're on to number 4. All right, so we have another implicit differentiation. So if I take the derivative of x is just 1, derivative of y is y prime is equal to product rule yet again. You should be seeing the similarity. You're going to get a lot of x, y's. I'm going to be giving you one on the pretest, one on the test. You should know how to take the derivative kind of without doing 1d2 plus 2d1 out on paper. You can just do it in your head. So it should be x y prime plus y. And then from there, I'm going to just rearrange, get all y primes on one side. So I'm just gonna randomly choose the right-hand side. So I'm gonna get rid of the y. I'm gonna subtract y, subtract y, and I'm also gonna move this y prime. So subtract y prime, subtract y prime, and when I do that, I get 1 minus y on the left. These cancel out, so I get x y prime minus y prime. Factor out of y prime, I'm left with y prime on the outside is x minus 1. That's our 5-minute warning. Is equal to 1 minus y. I'm going to divide both sides by x minus 1. I get y prime is equal to 1 minus y all over x minus 1. Oh, that's an answer C. Just to show you a different form that you could get, you could multiply this by -1 and -1. So if I did that, let me copy and paste here real quick. If I had this equation and I multiplied that by -1 over -1, that is equal to -1 plus y all over -x plus 1, which can be rewritten as y minus 1 all over 1 minus x. So this form and this form are exactly the same.
So there's 2 answers.
There's one answer. There's just rewritten in a different form. So make sure that you know that those are 2 of the same form. I'm going to say same answer here. I didn't realize I was still on.
It's just one of them would have a negative factor then?
Yeah, but since -1 over -1 is still 1, it is exactly the same answer. And then finally, number 5. Oh boy, yeah. So we have to find the inflection point first. So definition of inflection point. Go. F double prime sign change. That means we have to find the second derivative. First derivative is 3x squared minus 12x. Second derivative is y double prime is equal to 6x minus 12. Factor that thing. 6 times x minus 2. Set that equal to 0, and I know that this is a power of 1, so it's an odd power. That means my inflection point is that x is equal to 2. So I know my x is 2. I can come down here and set up my boxes. Y minus box is equal to box times x minus box. I know that my first x coordinate is 2. If I plug in 2, I'm going to get, I'll do this over here, y is equal to 2 to the power of 3 minus 6 times 2 to the power of 2. This is going to be equal to 8. 2 to the power of 2 is 4. 4 times 6 is 24, so minus 24, which is equal to -16. So my y is minus 16, minus 16. And then I need to find slope. Slope is where I take the derivative. Let's do that in black. So my y prime, I'll do that down here, sure. I'll kind of do a squiggly. My y prime now is, I've already done that. It's right here. I just need to plug in my x coordinate, which is positive 2. When I plug in positive 2, I get 3 times 2 squared minus 12 times 2, 12 times 2. And that's going to be 2 squared is 4, 4 times 3 is 12, minus 24, which is equal to negative 12. So my slope here is negative 12. A bunch of them have a slope of negative 12, not C and E though. Then I have to do some rearranging here. So if I distribute this negative 12, I'm going to get negative 12x. Negative 12 times negative 2 is a positive 24. But I also need to, this was a y plus 16 on the left hand. I have to subtract 16, so I get is equal to negative 12x. If I subtract 16, is that going to be 8, I think?
Wait, aren't you adding? Oh, wait, never mind.
Yeah, it's double negative, so it's a positive, and I have to undo adding 16, so it's subtracting 16. So y is equal to negative 12x plus 8. It looks like the answer is, oops, don't know what happened there, A. All right, so we have exactly 1 minute left of class. I need you at the very top to tell me exactly how many you got out of 5. Nice. Oh, no. Oh, nice. Nice. What happened, Sego?
I don't know.
Okay.
Mr. Stuff, my print's not working.
It might run out of ink.
No, it's not.
We can discuss it in a sec, but make sure we are studying. The pre-test is tomorrow. Treat it like the test. Be scared of the test, so you're scared into studying. And then once you're taking the test, don't be scared anymore because that causes test anxiety. But pretend it's the test. Pretend like, oh no, I need to study for the test tonight. Study tonight. Redo these self-checks. They are online. They're blank. You can print them out and do them again. You can print them out right now while you're waiting for the bell to ring. Do them again. Study. Study hard. That way when the pre-test rolls around, you'll be relaxed like, oh, it's not the test. It'll be fine. You'll do well, and then you'll do even better for the test. Study. Please, please. All right, that's the end of class.